Accelerated algebra 2 stirp here. So this is the inputs for 6E. We're going to be adding, subtracting, multiplying polynomials. So let's get started. So let's talk about the end behavior. So this is raised to the 5th power. And things that are raised to the 5th power typically look like this. If they are to an odd number, it would look like this. If you had a negative out in front, if there was a negative out in front of that 3 on that original problem, it would actually look like this. Okay, so those are for the odd powers right now. So we have an odd power. So as I go to the right, my graph goes up. So the function at x goes to infinity. As I go to the left, and this is the graph we're looking at, as I go to the left on this graph, the function at x, the y's, go to negative infinity. Okay, if we have an even power like this, they go either like this, okay? If you have a negative up front, like our situation, it actually goes downward, okay? So this is an even power where I have a negative out in front of the lead coefficient. So as I go to the right, as I go to infinity, my graph goes to negative infinity, so it goes down. And as I go to negative infinity, as I go to the left, my graph also goes down. Okay, so just kind of getting to become aware of, you know, if you have ax to an even, the graph looks like this. If it's negative ax to an even, it goes down. If I get ax raised to an odd, it looks like this. If it's negative ax to an odd, then it looks like this. So you got to kind of keep those in mind. Okay. Make sure during our online lessons, when we see each other on the computer, if you have questions about this, please ask. All right, when we are adding or subtracting, so we're going to look at like terms. So this is a like term with this. Okay, the reason they're like terms is they both have an x squared. So I get 3 minus 4, so I get negative x squared. And then this is a like term with this, so negative 7x plus 5 is negative 2x. And both of those, that would give me plus 4. So we added those together. When we multiply, we're going to distribute like we normally would. So I have 6x squared minus 24x. And that's all done. This one would be more of a FOIL situation. So you'd get x squared minus 11x minus 7x plus 77. Combine like terms, because those are like terms. Let's go ahead and FOIL this one. So I'm going to get 9x squared. Oops, I hit the wrong thing. So I'm going to get 9x squared plus 12x, or minus 12x. I should have made a minus right there. Sorry about that. Minus 16. My middle terms cancel out, so this is a difference of 2 squares. And then if I had this, I have to realize that that's x plus 9 times x plus 9. If I FOIL this out, it's going to be x squared plus 9x plus 81. So x squared plus 18x plus 81. That's how we would do that. What if we were to multiply? Kind of big, sorry. I'm going to distribute this 5, or this x here, here, and here. So I'm going to get x to the third minus 3x squared minus 6x. Let's change colors. Then I'm going to distribute the 5 same way. So plus 5x squared minus 15x minus 30. And then we do have some like terms. So I don't have any other x to the third, so that's done. X to the second, if I combine those together, is going to give me plus 2x squared. Combine those together, that's going to give me negative 21x. And then we have a negative 30. So you get that big old string of stuff. Same exact idea we had done before. Distribute the 2x squared, so I get 2x to the third minus 10x squared minus 14x plus 3x squared minus 15x minus 21. Combine like terms, 2x to the third. Have those as like terms, so minus 7x squared. Combine those, minus 29x minus 21. This one's done the same. Okay, just make sure you distribute the x here, 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 and then the negative x here, here, and here. Combine like terms. All right, this one's kind of a simplify. So we have a couple sets of parentheses. Make sure we take care of the operation prior to the parentheses on each. So I get 3x squared minus 12x. Distribute the negative here and here. Negative 2 plus x squared. And then distribute the positive 5x. Let's combine any like terms we have. So 3 plus 1x, or 3x squared plus 1x squared is 4x squared. 4x squared minus 5x squared is negative x squared. Plus 8x minus 2. We're all done. So factoring higher degrees. So when we do the factoring of higher degrees, there's a couple of ways that we can think about it. I would think about this if this was y squared minus 16. It would be y plus 4 and y minus 4. It's the exact same type of operation with this, but I'm going to have x squareds on each of my terms. So x squared minus 4 and x squared plus 4. This can be broken down because that's the difference of 2 squares. So I get x plus 2, x minus 2. And then I get, oops, that should have been a plus 4. Then I get x squared plus 4. That will not factor. Okay, sum of 2 squares will not break down. So let's take that same exact operation and think about with this one. So this would work as x squared minus 9 and x squared minus 1. If I FOILed that out, I'd get x to the 4th minus 10x squared plus 9. We have two sets of difference of 2 squares, so that's going to give me x plus 3 and x minus 3. And x squared minus 1 also breaks down to x plus 1 and x minus 1, because that's also the difference of 2 squares. So you want to make sure you factor these all together and break it down to binomials best you can. Okay, that's it. Take a look at the homework, and I think if we were to look at the homework, I think doing just the odds would be fine, and we'll check that online. All right, my friends, have a great day. Take care of one another. Bye-bye.